All right, so we need to use our calculator to do something like this. It's tough to try to factor something like this. So we're going to put it in our calculator, go to our y equals, okay, and plug it in there. Thanks, Austin. Okay, so we do our 2x to the fourth minus 17x to the third plus 4x squared plus 35x minus 24. Okay, now remember, when we look at this, the zeros are where when we look at this? Come on, help me out. Yeah, the zeros are the zeros, but what do I look? Once I hit graph, what am I looking?
On the graph.
The x-axis, right? Where the graph touches or crosses the x-axis. We all realize that, right? Okay, so we hit graph, or I have to hit enter first, sorry. Hit graph, and then I'm watching where it hits the x-axis. So it went straight through, bounced off, went straight through. Okay? So when we see it bounce off, what are we thinking? It works twice, right? At least. It has multiplicity if it bounces off. It has even multiplicity. So we're thinking it works twice. So are we seeing all of them?
Yeah.
There's one. If it works twice there's two. That's three. And then that one would be four, right? We're going to see all of them. Remember this exponent here, this leading coefficient, this leading term, first term, whatever that exponent is how many zeros there should be. Okay? Now sometimes you won't see them all. Okay? That's what we're going to get into a little bit more this week as well. Okay, so I'm going to go to the table. Well, let's do this first. Show our graph. So remember, oops. Remember, we're looking for our zeros. That point, that looks like a 1, and this one. 1, 2, 3, 4, 5, 6, 7. That looks like 8. That looks like 1. That looks like maybe negative 1.5. Okay? But I'm going to go to my table in my calculator to make sure I'm right on what I'm thinking. All right? How do I get the table again? Second graph, right? Where it says table above graph, right? So 1 is correct. All right, I know it's between negative 1 and 2. We can tell, plus at negative 2 it's positive number for y, and negative 1 it's negative, so you know it goes between, it goes through the 0 when it goes between those. So 1 was okay, and 8 was right, okay? Again, you're looking on the table, you're looking where the y is 0. You know, when you look at the graph, you're looking where it touches the x-axis, but the y value is 0, okay? That's what you look at in the table. So this is an 8. Oops. Let me back up. That's an 8. This is a 1. And this one we got to figure out, okay? Now, if you don't, let me just show you how to figure it out. Just because this is something you have to do anyway on the ones that you can't see. Okay, we can see all 4 of these, but the ones we can't see, sometimes those non-real ones, those imaginary ones, we have to do this anyway. So I'm going to use 1 first, and I got in my synthetic division 2. It goes 4, 3, 2, 1, a constant, so I don't have to add any zeros. Remember that 17's negative because of the minus sign. And then the 24 is negative because of the minus sign. Draw a line, remember we drop the 2 down below, and I multiply 1 times the 2. Okay, that gives me 2. And then I add these, that's negative 15. And 1 times negative 15 gives me that negative 15, and then I add those, and that's negative 11. And 1 times negative 11, negative 11, and that's a 24. And 1 times 24 is 24. And I get a 0, which is supposed to happen, right? We all realize that has to be 0 when we do this, right? Because it told us that it's a 0. Now, since it bounced, we're thinking 1 works again, right? So I'm going to use 1 again, Connor. Come back to me, don't zone out already. 1 times 2 is 2, I get a negative 13. 1 times negative 13, add those, I get negative 24. 1 times negative 24, I get 0 again. So it did work twice. Okay. Then I'm going to use the 8. It goes straight through. It only works once then, right? 8 times 2 is 16. I get a 3. 8 times 3 is 24. I get 0. Okay? So remember, originally, this was 2x to the 4th, right? And then as we do synthetic division each time, that exponent gets 1 less. Because we've told you that, right? That's what's happening. The polynomial, each time I divide, it's being reduced. The degree of it. So it went from to the 4th power to the degree of 4, degree of 3, degree of 2. Now it's at a degree of 1. So this is the problem right here. 2x plus 3 equals 0 is the problem I got to solve to get that last 0. Okay? If it works out that you can't see all 4 of them like we can on this one, it's probably only going to get down to an x squared. Then you're going to have to use the quadratic formula to solve it. But this one is easy to solve. Some of you were trying to do this the other day on the quiz, which is fine because we've done this. But you weren't making this the right. You were thinking this one here was the x squared, but this was the x. So you just do that problem, and you'll get what we thought it was. What's negative 3 divided by 2? Isn't that negative 1.5? That's what we thought it was, didn't we? Right. So there's our 4 zeros. Negative 1.5, 1, 2 times, multiplicity of 2 because it bounced, and 8. There's my 4 zeros. That's basically what we did on the quiz Friday, right? Now, let me show you how to find that on your calculator if you want. You can find that one since you can see it. You hit second trace, the button next to graph, and we're looking for a 0. So I hit 2. Okay, so it's going to say left bound. So this is the one I'm looking for. All right, I have to get left of it. Okay, left of it would be above it. All right, so it's going to go down a little bit. Now it's coming back up. There it is. Okay, there's that negative 1. If I go left one more, it's at 28. It's way up there. Okay, that means I'm left of it. Hit enter. Right bound. Below it means I'm right of it. Hit enter, and then guess. And what's it going to tell us when I hit guess now? What's it going to tell us? The negative 1.5. Okay? So if you can see it, you can go ahead and use the calculator to find all of it. But I wanted to show you, if you can't see it, this is what you're going to have to do. Questions? So basically what we did last week, right? We good so far? All right, I'd like you to try this one down here on your own, please. Go ahead and try it, and then we'll go over here in a few minutes, just to see if we're getting, making sure we got the hang of this. Austin, you got a calculator, right? Good. Yes, sir.
I'm not gonna be.
Where are you going? For what? Snowboarding? Will get hurt? 2 days?
Yeah, we're going to Colorado.
Ooh, that'll be fun. Get some big hills, huh?
No problem.
What do you want? Well, what would you do last year? All weekend? Nothing.
I'm fine. We're gonna have your own.
Everybody go over your book. Put this arm off. Chili and handles, you know? Left it where? Well, you were certain side of the kitchen on Friday, isn't that what you told me now? Well, you can pull stuff out of it. Get in there better. Okay, what are they?
Yeah, there's a first floor appointment came on. That's part of the plan to keep going. Had a couple of food. Big, and there's some. Yeah, I thought this one was there. But they were.
She's not going. Nice. Right picture.
They have a little.
Where's your picture? You gotta put your Y equals there. Yeah. Put your 6 there. I don't see any. Hit that button. Yeah, did you put it in there? It's gray enough now.
Why is there more?
Shows up in the tables that they show up on the graph.
Going up. Oh, there's what?
Does it?
Forgot an X. That doesn't look right. It's not like, the Eagles.
Yeah, that's what I mean, like the good news.
All right, put it back in. Something, you had something extra. All right, everybody knows how to put it in, right? I hit graph. Okay, bounced. So I see all four of them, don't I? This is what it should look like. Okay, it bounced here. It looks like -2 to me. And then there's a point, and there's a point that I can't tell. Okay? Because it's between 0 and -1 and between 0 and 1. If I go to my table and go to -2, I was right, it's at -2. Okay? But it bounced, so that says I can say it works 2 times. When it bounces, it works an even number of times. And it's only going to be 2 because I got 2 others and I need a total of 4, right? If I was looking for 6, and that's what I saw, this was 6x to the 6th, and that's what it looks like. This probably works 4 times. Okay? So, again, just to use my synthetic 6, 23, 19, -8, -4. That's a -12, which is what, 11? -22, which is -3. +6, which is -2. +4 is 0. Work. Right? Then I need to do it again. -12, -1, +2, -1, +2, 0. Okay? So, I can figure this out, the other two, with the quadratic formula now. That was x to the 4th, that's x cubed, that's x squared. Okay, so this problem here is 6x squared minus 1x minus 1 equals 0. That's what that problem is. So we can use the quadratic formula. X equals -b plus or minus square root of b squared minus 4 times a times c. Remember, that's the a, -1's the b, -1's the c. Over 2a. Okay, so that's a positive 1. That's 12. All right, -1 squared is 1. -4 times 6 is -24 times -1 is positive 24. What's 1 plus 24? What's the square root of 25? 5. So this was my problem. There's 2 problems there. Okay? 1 plus 5 over 12 is 6 over 12, which is 1/2, right? And then 1 minus, I'll do it over here. One minus 5 is -4 over 12, which is -1/3. Okay? So this one here is a -1/3, and that one there is positive 1/2. So there's my -2 twice, -1/3, and 1/2. Okay? Now you could find those also in your calculator. One was point That was negative 0.3 repeating. You used your calculator and that was 0.5. That's fine. Any questions? Same old stuff as last week, right? Okay. The other part of this week is they'll give you the answers. You got to go back and find the polynomial that goes with it. Okay? So we're going backwards. When you start these, you always start x minus. Since there's 3 of them, I put 3x minus, whoops, let me do something there. Okay? So you just put the numbers. So 4, negative 3, but what is minus a negative 3? What are you going to change it to? You're going to change it to addition, right? Now, when it's a fraction like this, the denominator goes in front of the x, and the numerator goes after the minus. That way you won't have fractions when you do it. And then what do I do to get the polynomial? If there's nothing between these parentheses, what am I supposed to do with each one of those binomials? Multiply, right? You can only multiply 2 at a time, right? So just do the first 2. And we call it foiling, right? X times x is x squared. X times positive 3, remember, we made it minus a negative, we made it positive, so plus 3. Negative 4 times x, and negative 4 times 3. So I get x squared minus 1x minus 12, and then I multiply it by 3x minus 2. Okay? When I have a trinomial times a binomial, I take this first term and multiply it. Oops. So let's do this. Multiply it by both. So that's 3x to the third and negative 2x squared. Then I take the middle term times both. Negative 1x times 3x is negative 3x squared. And negative 1x times negative 2 is a positive 2x. And then I take the third one times both of those. Negative 12 times 3x is negative 36x. And negative 12 times negative 2 is a positive 24. So what I do is I line up the like terms as I go. If you want to put all 6 terms in a straight line, that's okay. And then we combine the like terms. Okay? So this answer, this polynomial, 3x cubed minus 5x squared minus 34x plus 24, if I put that in my calculator and look at it, it would cross the x-axis at positive 4, negative 3, and 2/3. We're just going backwards. Okay, so we always start x minus for those. Questions? All right. Sometimes, like I talked about, you can't see the zeros. They're imaginary. So, if these were the zeros to a problem, which we're going to figure out what that problem is, to a polynomial, I wouldn't be able to see any of them. Okay? So, again, we just do x minus. So there's 4 of them. When they're imaginary like this, they're called, complex numbers. They come in pairs. Okay, if there's a 2i as a 0, there's also a negative 2i. If there's a 3 plus 7i as a 0, there's also going to be a 3 minus 7i. They come in pairs. If you have radical numbers, irrational numbers, if there was a radical 5 as an answer, there's also a negative radical 5 as an answer. They come in pairs. So with radicals or with the i's, they come in pairs. And then you just write these in. You got 2i, and you're going to put negative 2i, but what is x minus a negative 2i? Minus a negative? Come on. I know it's Monday. You guys can still tell me it's what? What's minus a negative 2i? Plus, thank you. Now here's where some people mess up. Always do the x minus and then just write those. And the 3 minus 7. Just write it like that. Okay, so when you see minus a negative, you're going to put the plus. But when you see these, just put minus and then the 3 plus 7i and the 3 minus 7i. Now, you have to do these in a certain order. You have to do the paired ones together. You have to multiply those two together. You have to multiply these two together. Because what's going to happen to those i's if I do that? They're going to go away. They will get eliminated. Okay? So you have to, we call them conjugate pairs. All right? You have to FOIL the conjugate pairs together. All right? So I got x times x, x times 2y. I always go ix because that's alphabetical order. But if you want to write xi, that's fine. Just make sure you write the other one xi. Negative 2i times x. And negative 2i times a positive 2i is negative 4i squared. Remember, what's I squared equal? Negative 1. Thank you. So, as you can see, the 2ix and the negative 2ix will do what? Cancel out. Remember, since I squared is negative 1, this is negative 4 times negative 1, which is what? Positive 4. So this answer is x squared plus 4. No more i's. Now this one I got 3 terms, times 3 terms. So when I multiply, there's going to be 9 of them. Okay, Mason? All right, so make sure you get 9 answers here. So you go x times x, x times negative 3, and x times negative 7i. So that x times all 3 of these. And I take this middle one. Make that black so it doesn't mess things up. All right, so negative 3 times x is another 3f, negative 3x. Negative 3 times negative 3 is a positive 9. And negative 3 times a negative 7i is a positive 21i. All right, so there's 6 of them. Positive 7i times x is positive 7ix. Positive 7i times negative 3 is negative 21i. So what's going to happen to the ix and that I? They cancel. And then positive 7i and a negative 7i is a negative 49i squared. I put it under the 9, why? What happens to that I squared? It's a negative 1, right? So it's negative 45 times negative 1, which makes, 49 times negative 1 is a positive 49, right? So this answer would be x squared minus 6x. Is that 58 when I add those? So to finish up, I just multiply the red binomial times the green trinomial. I wanted to show you this part so that you would believe me when I tell you that the i's will go away as long as you put, when you multiply the pairs together, the conjugate pairs, then your i's will go away. It gets kind of messy if you try to mix them up. It'll still work out, but it gets messy. All right, and then from there, you can finish it, right? Any questions? All right, so I'm gonna have you do 2 of finding zeros and 2 of given the zeros and finding the problem, okay? 4 problems for homework. Any questions? Okay, there you go.